This is test number 3 from series 2. This is mainly based on simple harmonic motion and wave properties. We'll move to the first question. Variation of displacement of a point with time t in a progressive wave that which the point is at a distance x by the equation y equals a sine this equation. So what they are asking is dimensions of b over c. So this is the equation y equals a sine bt minus cx. So what they ask is dimensions of b over c. They say that this x is a displacement, so the dimensions capital L, simple t is time, dimensions capital T. So what they ask is what is the dimensions of b over c. So you know that inside a sine function, so this is sine, inside the sine function it is always an angle. That could be in degrees or in radians. So you know that angles don't have a dimension, meaning they are dimensionless. Angles are dimensionless. So this whole part does not have dimension. So we can say dimensions of this whole thing is just 1. Because this is an angle. Because it was inside sine. Okay, so these each term as well should not have dimensions. They should also be dimensionless because this is separated by the minus sign. These are terms. So bt and cx, the dimensions is equal to 1. Dimensionless. Okay, then I'll keep b. Dimensions of t is capital T. C. Dimensions of x is capital F. So what we need is b over c. So b over c dimensions, if you cross multiply that, this becomes L, t goes to the denominator. So this is L t minus 1. So this is dimensions of b over c. That is L t minus 1. So the answer should be the second one for the first question. Second question, displacement y of a particle is given by y equals 10 sine 4t plus 5. Time period is seconds is. So this is the equation in simple harmonic motion for displacement. So the common equation is this one, capital A amplitude sine omega t plus 5. Omega angular velocity, then this phi is the phase angle or the phase difference. So what we need is a time period. So time period is involved with this omega, that is angular velocity, related to the circular motion, simple harmonic motion. So if you compare these two equations, you can say that omega is equal to 4. That is all we need. So the other equation for omega is also equal to 2 pi divided by the time period, omega. So this is equal to 4. If you cross multiply, t equals 2 pi divided by 4. So this becomes 5 over 2. That is the time period, 5 over 2. So the fifth answer for the second question. Third question. Object in simple harmonic motion has a time period 6 seconds. So capital T, 6 seconds. And amplitude of 3 centimeters. Its maximum speed in centimeters per second is. So you should remember the equation for maximum speed. So the Vmax is equal to amplitude times omega. they have given amplitude, so it is just 3 centimeters. Omega, we know that omega is, instead of omega, we can use 2 pi divided by capital T. 3 centimeters, 2 pi divided by capital T is given as 6 seconds. So 1, 2, cancel. Then this becomes 5 centimeters per second. Fourth question. Object in SHM has time period of capital T, amplitude capital A. If the speed at the center is v, its maximum acceleration is. So now they are asking for the maximum acceleration. So to do this question, you could have done this if you just remember these equations, right? Okay, the time period is capital T, amplitude capital A. Speed at the center is v. So you know that in simple harmonic motion, at the center it has the maximum speed. That maximum speed, they say, that is v. So I'll just first write the equation for maximum speed, that is a omega. You can directly apply these equations even in an essay question, right? These are standard equations. You don't have to prove these. Okay, so V max, they say that V max is V. Then amplitude is just given as capital A. Amplitude is capital A. Right. Then this omega. I'm not going to substitute capital T here. I can write omega in terms of 2 pi over T. But if you look at these options in the answers, we won't get an answer if you use 2 pi over T. So I'll just leave omega as just omega. Because we are going to need this omega when we need to find maximum acceleration. So I'm keeping omega here without doing a substitution for time period. So from this one you can find omega, that is V over A, cross multiply. Right. Then what they ask is acceleration. So this is the equation for acceleration. This is the acceleration in general. Omega squared x. X is the displacement. But here what they ask is maximum acceleration. So for the acceleration to be maximum, this x should be maximum. Maximum x is at an amplitude. That is the amplitude. So at the amplitude we have the maximum acceleration. So for A max, I'll just omit this negative sign for now. Omega squared A. So the maximum acceleration, equation for maximum acceleration is omega squared A. That is amplitude. Right. Here we got an expression for omega, that is V over A. I substituted it here. So this becomes V squared A squared times A. So this is answer 1A, V squared divided by A. That is the maximum acceleration, V squared over A. So that is the answer to this third one for the fourth question. Fifth question. An object in SHM has an amplitude of simple A, frequency B over 2 pi. Maximum acceleration is. So again they are asking for the maximum acceleration. So we know that the equation for maximum acceleration is omega squared A. Since they are only asking for the magnitude, I'll just avoid negative sign. Okay, they say, so the amplitude, capital A, they say as simple A. And the frequency is given as B divided by 2 pi. Right. So here we have amplitude, we need omega, an expression for omega. So we know that omega is 2 pi over capital T. Just remember one equation. If you can remember at once, it's fine, but at least you have to remember one equation. 2 pi divided by capital T. So that is comprehensible. So just remember this. 2 pi divided by capital T. So this is 1 over capital T. Instead of 1 over capital T, I can put 1 over capital T, that is 1 over time period, is the frequency. So instead of 1 over capital T, we can put 2 pi simple f. So now the equation for omega is 2 pi simple f. You can directly use this. But if you don't remember, just at least remember one equation. Then you can derive that another equation quickly. Right, omega is 2 pi f. 2 pi, simple f, we know that b over 2 pi, that is given as b over 2 pi. So 2 pi cancels, b. Okay, now we have term for omega, that is b. Term for amplitude, simple a. Now just substitute it here. Omega is simple b, so this becomes b squared. Amplitude is simple a. So a max here is b squared simple a. Answer should be third one for the fifth question. A man weighing 50 kilograms is sitting on a weighing scale. If the weighing scale is in simple harmonic motion vertically with displacement 0.05 meters and with frequency 2 Hz, maximum and minimum readings of the scale is. So there's this man sitting on a scale. Let's say this is a pressure scale. So weight of the man is 50 kilogram, or else we can say 500 newtons. Then there's a reaction force capital R. You should know that this reaction force capital R is what becomes the reading of the scale. So this is actually the, just remember like that, under any circumstance, this capital R is the reading of the scale, regardless of the situation. This should be the reading. Then let's say, so it is like oscillating vertically, goes up and down, up and down. So what they are asking is, so this is showing different readings as it depending on the acceleration at each stage. So the acceleration is constantly changing. I'll just say acceleration, let's say going upwards in general. If I just apply the equations, F equals ma, this becomes R minus 500 equals mass is 50 times simple A. So R is 500 plus 50A. So this is the equation. R equals 500 plus 50A. Right. So this A can vary from 0 to negative acceleration to positive maximum acceleration. Negative maximum acceleration to positive maximum acceleration. Right? So this can vary like that. So let's say at the top, so it is oscillating like this, and at the top it has a negative maximum acceleration. If I consider that this to be the positive side, acceleration is downwards at this point. And at the amplitude, it has a maximum negative acceleration. At this point, at this instant. And at the bottom, it has a maximum positive acceleration. Now the acceleration is, you know that acceleration always is pointing towards the center of the simple harmonic motion. Right. So this is negative acceleration and positive acceleration. So if you can see, R max is maximum R becomes maximum when acceleration is maximum. A max. R becomes minimum if acceleration is A min. Sorry, A max but negative. First we will find maximum acceleration, magnitude of maximum acceleration. So maximum acceleration is A omega squared. I'll just omit negative sign. I just need the magnitude here. Okay, so the amplitude is given as 0.05. Frequency is 2 Hz. You know that omega is 2 pi f. 2 pi frequency. Frequency squared. 0.05. 2 pi squared means 4 pi squared f squared. 0.05. 4 pi squared. 5 square is approximately equal to like is 9 point something, 9.8 something. Approximately we can say that 5 square is 10. Frequency is 2 Hz, so 2 square means 4, right? So this is 0.5 times 16. 16 times 0.5 is 8. 16 times 0.5 means half. Right. So the maximum acceleration, magnitude of acceleration maximum is 8 meters per square second. Well, we just found it. Then for R max 500, it should be 50. Maximum acceleration is 8. So this is 40. Sorry, 400. Okay, so the maximum reading becomes 900 Newton. Maximum reading becomes 900 Newton. Then the minimum reading should be 500 plus 50 times. Minimum acceleration is not 0. Minimum acceleration is negative 8. Negative 8. So that occurs at the top. Here it has a negative acceleration. So it's going to be the minimum reading. So this is 500 minus 400. So that is 100 Newton. So the maximum reading is 900 Newton, minimum reading is 100 Newton. So the answer for that question should be maximum and minimum, fifth one for the sixth question. Seventh question. 4 kilogram of mass in simple harmonic motion has a variation of potential energy EP with displacement as shown below. This is the graph for that motion. So what they ask is a time period in seconds. Time period in seconds. Right. So from this graph, what we can grab is, so this is the maximum displacement, 0.2. That is the maximum displacement. Because there's no any other displacement after that. So 0.2 meters is the maximum displacement. So what we need is time period in seconds. Right, so amplitude, we found that. Other one you can find is this maximum potential energy. The maximum value of the potential energy, that is just 1 joule, maximum potential energy. Right. So if you understand the variation of simple energy in simple harmonic motion, I'll just further explain that. So at the center, it has a maximum kinetic energy. Here at the amplitude, kinetic energy is 0. At the amplitude, kinetic energy is 0. At the center, it has a maximum kinetic energy. Maximum kinetic energy means all the energy at the center is total energy of the motion at the center is only as kinetic energy at the center. So at the amplitudes, kinetic energy, because it is at rest instantaneously it is at rest at the amplitude. So kinetic energy at the amplitude is zero, meaning that all total energy at the amplitude should be in as potential energy. So at this amplitude, it has a maximum potential energy. Okay. So how that varies? You know that kinetic energy and potential energy, that is the total energy. Kinetic energy plus potential energy, that is the total energy of the simple harmonic motion. Then, if you think about like kinetic energy, maximum kinetic energy is also because at the maximum, if the kinetic energy is the maximum, the total energy, the whole energy of the motion is as kinetic energy. So that should be equal to the total energy as well. This total energy also is equal to PE max, because like total energy of the simple harmonic motion is as potential energy at the amplitudes, and at the center total energy is as kinetic energy. So kinetic energy maximum and potential energy maximum should be equal to total energy. But here we only need, you know that this is the maximum potential energy, that is 1 joule. So that is equal to Ke max. Ke max. Maximum kinetic energy. Okay, so the equation for the kinetic energy, we know that half m v should be v max squared. Then I will put 2 here, cross multiply. 2 equals, the mass is given as 4 kilogram, times V max. The equation for V max is A omega. Omega squared. Right. So 2 equals 4 times A is amplitude, we know that 0.2 omega squared. 0.2 omega squared. So what they ask is time period. So this is squared here. 0.2 squared is 0.04 omega squared. Omega squared. Instead of omega, I can put 2 pi over t. 2 pi over t. Right. Then just a simplification. 1, 2. If you cross multiply that, this is 1 over 2. 0.04. This is 4 phi square divided by t square. 4 phi square divided by t square. Then this is 1 over 2 equals 0.04 means 4 divided by 100. 4 divided by 100 times 4 phi square divided by t square. 125. If you cross multiply, 25 divided by 8. 25 divided by 8. I'll put 5 squared also at the other step. 5 squared equals 1 over t squared. If you flip that, both sides, t squared is equal to 8 5 squared divided by 25. Then t, take the root from the both sides. T is root 8 5 divided by 5. So root 8 is 2 root 2. 5 divided by 5. So this is the time period. So the answer should be the fifth one for the Seventh question. 2 root 2 5 divided by 5 seconds. So the question, there are some sort of simplifications, but once you get used to these equations, it is not a complicated question. Right, 8. Two men at two ends of a metal pipe with length simple d. One of the men fires a gun. Other man at the other end hears the sound of it one after the another at a gap 10 seconds. If the sound speed in metal and AR are 630 meters per second and 330 meters per second, simple d is equal to, right? So after this one, these are properties of waves questions, right? So they're asking the question is regarding sound velocity in different mediums, right? So let's say this is the road, length of the road. There's one man, and he shoots a bullet, so it makes a noise here. So this creates a sound wave which propagates through air, and another one propagates through the metal. So the man at the other end hears a sound that propagated through the metal first. Then after 10 seconds, the sound wave propagated through air is heard by this man. So there's a gap. So he hears the sound twice. There's a gap between those sounds. After 10 seconds, he hears the sound of the firing after 10 seconds. Right. So this also is not a complicated question. You can treat these sound waves as objects that are moving at constant velocities. Waves do not accelerate. Waves always have a constant velocity in a medium. Constant velocity in a medium. Velocity of a wave only changes if the medium changes. Right. So here through here, the velocity is 3630 meters per second. The velocity of air is 330 meters per second. Right. So what this has is a time gap. Let's say for the air, for the sound in air takes t1 amount of time, and sound through the metal pipe takes t2 amount of time. So this reaches quickly. So this value should be the less value. This is the large value. So t1 minus t2, this should be equal to 10 seconds. That time gap should be equal to 10. t1, you know that s equals ut. Let's say s equal ut. S is the same distance. It doesn't change. That is simple d. If I apply this, let's say time is equal to d divided by u. So instead of t1, I can put distance is simple d, speed is 330 minus through the metal pipe, distance is still simple d, and the velocity is 3630 equals 10. Right. So here, then there's a simplification. Further, the simplification will be easier if you see this. This 3630, this is actually 330 times 11. If you saw that, then the calculation is going to be easy. (330 times 11 equals 10). So I will take the common denominator. So it should be 330 times 11. I'll take d out, and inside it becomes 11 minus 1. 11 minus 1. This is equal to 10. 11 minus 1, that is, we know that is 10, right? 10. So let's cancel this one. 1, 10. Just divide the both sides by 10. Then d is equal to cross multiply 330 times 11. So 330 times 11 is 3630. We already know that. So usually, in most cases, for an MCQ, they don't give complicated calculations. They give something like this. So you have to have the ability to spot this. Otherwise, to solve MCQs, it would take simplifications would take a long time. You can save time. There's always, in almost all the cases, as in especially in MCQs, there are some shortcuts to do simplifications, right? So the answer here should be 33630 meters. Fourth one is the answer for 8th question. Ninth question. Ratio between wavelengths caused by two identical vibrating sources is 1:3. Ratio between speeds of the waves is. So they are like sound sources. They have given the ratio for wavelength. So that is 1:3. So what they ask is a ratio between speeds of the wave. So these waves are released to the same medium. The sources are different, but they are released to the same medium. The point of this question is if the medium is the same, regardless of the wavelength or the frequency, speeds are the same. Speeds cannot change. Speed only depends on the type of medium. Speed only depends on the type of medium. Let's say if I have the same medium, and let's say I need to quickly I need to increase the speed of the wave. Let's say like a water wave or something. So if I like a wave in a string. So if I quickly vibrate the other end of the string, the wave would not move faster. It would have the same velocity. So this equation, V equals F lambda. So if I increase frequency, only thing that happens is lambda decreases by the same factor. If I increase the frequency, lambda decreases by the same factor. V does not change. We cannot change V by increasing the wavelength or the frequency. So whenever we increase frequency, lambda decreases. Or if we decrease frequency, lambda increases. Or if we, in other ways, we cannot have like larger wavelength and velocity. So only these two changes, because velocity only depends on the medium for waves, right? So in that case, in both cases, it is the same velocity regardless of the wavelength. So the answer should be 1:1 for velocity. It doesn't change. Velocity is 1:1. So the answer is fifth one for the 9th question. 10th question. Beat frequency due to superposition of waves represented by y1 equals 5 sine 100 phi t. Then y2 equals 5 sine 104 phi t. So those are the two waves. What they ask is beat frequency. So here so the common equation is y equals a sine omega t. So instead of omega, I can use 2. So omega is equal to 2 phi f. Right? So instead of omega here, I can use 2 phi f t. So from that, we know that for this question one, 2 phi f is equal to 100 phi. According to this one equation, there is one equation. 2 phi f equals, let's say that is f1, 2 phi f1. So for the other equation, 2 phi f2 is equal to 104 phi. Then I'll find f1. F1 is 5 phi cancels, so 50 hertz. f2 is equal to 5 phi cancels, so 52. So f2 is 52, f1 is 50 hertz. So the beat frequency is f2 minus f1. Beat frequency is just the difference of frequencies. Remember this equation? fb is equal to f2 minus f1. Just the difference. So here f2 is 52, f1 is 50. Okay, so beat frequency is 2 hertz. Beat frequency is 2 hertz. So the answer for the 10th question should be second one. 11th question. Maximum and minimum incidence of a wave due to superposition of two waves of same frequency with intensities I and 4IR. Okay, so we have two waves. One has the intensity I, another one intensity 4I. One has intensity I, another one 4I. Right. So when these two waves gets to the superposition, what happens is the amplitudes of each wave increases. So here we need to find the amplitudes. So this one, intensity is proportional to amplitude is squared. Intensity is proportional to amplitude is squared. Let's say here the amplitude is A1, here the amplitude is A2. So if I just so I is proportional to A1 squared, 4I is proportional to A2 squared. If you divide 1 over 4 is equal to A1 square divided by A2 square. Take the root of the both sides. A over 2 equals A1 over A2. Okay, so for the two waves, intensity ratio is 1:4. Amplitude ratio is what? Amplitude ratio is 1:2. So meaning, if the amplitude of this one is capital A, amplitude of this one should be twice. So it should be 2A. Right? We know the amplitudes A and 2A. So if that is the case, A and 2A, when they are in superposition, those two amplitudes adds up and the amplitude becomes 3A. A plus 2A, that is 3A. Right. So they are not asking about the amplitude of the superposition wave, they are asking for the intensity. Again, we know this equation is A squared So if 3a gets squared, it becomes 9a squared. What does it mean? Initially it is a squared. Now the intensity should be 9 times. Intensity should be 9 times for the superposition wave. So the answer should be 9i. If amplitude it becomes like increased by 3 times, factor of 3, intensity should be increased by 9 times because intensity is proportional to amplitude squared. So the answer should be 9i. So that is a maximum intensity. The other case is if they are superpositioned in the opposite phase. These two amplitudes, like there is a destructive interference, gets cancelled off. In that case, the new amplitude is 2a minus a. Previously it was 2a plus a. So the intensity became 9i, 9 times. Now it is 2a minus a, that is a. Amplitude is just a for the superpositioned wave. So a squared is the new intensity, proportional to the new intensity. So from the destructive interference, the intensity should be I, which causes the minimum wavelength. So this is from the constructive interference. Intensity becomes 9i. So the answer should be 9i and I. It's a one wave, but if they are like in constructive interference, amplitude grows. If they are in destructive interference, amplitude shrinks. So the intensity also varies according to the amplitude, but intensity is always proportional to amplitude is squared, not amplitude is squared. 12th question. A taut string with length 2 meters vibrates causing 5 notes. 5 notes. Distance between two consecutive notes is. Okay, there also this has 5 notes. 2. So node is something like this one, right? It's a node. So 2, 3, 4, 5. Okay, so this has 5 notes. 1, 2, 3, 4, 5. 5 notes. So the length of the string is given as 2 meters. So what they ask is distance between two consecutive notes. So this is the distance between two nodes. Okay, so this has 4 loops. So the one of this is a loop. So this has 4 loops. So the distance should be the length of a loop. So that should be the distance between two nodes. So 2 meters divided by 4. That is the number of loops. You can find this. 2 divided by 4, that is 0.5 meters. 0.5 meters. Second one for the 12th question. 13th question. Property that distinguishes transverse waves from longitudinal waves is. Okay, they have given these properties are reflection, refraction, diffraction, interference, polarization. So like that transverse waves. So if the direction of wave is like this, particles in the medium vibrates like normal to that, perpendicular to the direction of the wave. If the wave is moving to this side, particles in the wave vibrates perpendicular to the direction of the wave in a transverse wave. So water waves, all the electromagnetic waves, waves in a string. Those kinds of waves are transverse waves. Longitudinal waves, basically longitudinal waves are like mainly like sound waves. Sound waves are longitudinal. For an example, particles in the medium vibrates parallel to the direction of the wave. So if the wave is moving to this side, particles are moving, vibrating to this side. Not like this, but like this. For longitudinal waves. So that is the main difference between transverse and longitudinal waves. One of the key property in to distinguish these two waves, transverse and longitudinal waves, is polarization. Like for a transverse wave, there's a particular plane for the transverse wave, but for longitudinal waves, it doesn't have a particular plane for the oscillations. So the polarization means like changing the plane. If you remember the theory parts, changing the plane of the oscillations. If longitudinal waves doesn't have a specific plane, then it cannot be polarized. Transverse waves can be polarized. Longitudinal waves cannot be polarized. So polarization is the main property that separate longitudinal and transverse waves. All the other properties happens in both cases. I'm not going to explain each property. Here it is only polarization that is used to separate longitudinal from transverse waves. So the answer should be the fifth one for the 13th. 14th question. If the refractive index of water is 4/3, speed of electromagnetic waves in air is 3 times 10 to the power 8 meters per second. Speed of electromagnetic waves in water is. So this equation. So this is absolute refractive index, that is equal to C divided by V. C is the speed, light is speed in a vacuum or in air, divided by V. V is the velocity in the medium. So here medium is water. Refractive index, absolute refractive index of water is 4/3. C, light speed, that is given as 3 times 10 to the power 8 divided by V. So here you need to find V. Okay, cross multiply. V goes to this side, 4 goes to other side. 3 times 3 10 to the power 8 divided by 4. 9 divided by 4, that is 2.25 times 10 to the power 8 meters per second. So in water, the speed of light is less, 2.25. So it is a denser medium compared to like a vacuum or air. So the answer should be first one for the 14th question. Right, 15th question. Speakers S1 and S2 shown in the image are connected to the same sound source. Sound waves caused by them are at the same phase. So meaning they are simultaneously operating. P is on the line which is between S1 and S2, and the bisector perpendicular to S1, S2. Line goes to P. When detector is at P, detects maximum sound intensity. When the detector is moved from P to Q at Q, it again detects maximum sound intensity. Right. So these two are the speakers. They are simultaneously like operating, so they are in the same phase and they have the same frequency. They are generating sound with same frequency, sound waves with same frequency. Then we have a detector here at P. They say it has a maximum intensity, meaning there's constructive interference. Constructive interference, I'm not going to explain the theories. So at P there's constructive interference. At constructive interference, you know that's why it has a maximum intensity. Maximum intensity means those waves have the maximum amplitude. Okay, at P there's constructive interference. At P. So this is the bisector. The P is on the bisector. So we know that this distance is S1P minus S2P. So these two lengths are the same, right? These two lengths are the same since this is on the bisector. Then the difference, we call that path difference. Path difference is actually 0 there. Actually 0. S1P minus S2P, that is 0. So if you move the detector to Q, they say at Q, again the detector notices a maximum intensity. Maximum intensity is at this point, again there is going to be constructive interference. Constructive interference. In order for the constructive interference to happen, this is the general equation S1Q minus S2Q equals n lambda. So if this is a consecutive case at Q, this n should be equal to 1. So that path difference is 0, or the path difference is a full multiple, integer multiple of lambda. That's always going to be constructive interference. Since this is right after P, then at this point n is going to be 1. So here path difference is just a one wavelength. So S1Q minus S2Q S1Q minus S2Q is equal to 1 lambda. Not n is 1, so this is equal to 1 lambda. So S1Q, you can find that length using Pythagoras theorem. So that is 3 and 4. So this length is 5. S2Q, this is 4. Okay, now we found lambda. So lambda is 1 meter. Then it is easy. Then just apply V equals F lambda. Sound velocity is given as 340 meters per second. Frequency times lambda is 1 meter. So frequency is 340 hertz. Frequency is 340 hertz for the sound sources S1 and S2. So the answer should be third one for the 15th question.